Here we have another empirical formula calculation, this time between manganese and oxygen. Same method as always. We're going to write the formula of manganese here, Mn. We're going to write the formula of oxygen there, O, because we're going to work out the ratio of manganese to oxygen in this compound, the simplest ratio, and that's the empirical formula. To do this, we need to know the formula moles equals mass over atomic mass. I'm going to use the abbreviation AR for atomic mass, and we're going to do that for both manganese and oxygen. So here's our mass of manganese in the question, 6.38 grams. We know it's a mass because it's got a unit after it. G for grams, that's a unit of mass, 6.93 I should say, 6.93. Divided by the atomic mass here is 55. 6.93 divided by 55. Let's have a go at that. And we're coming up with an answer there of 0.126 equals 0.126. Now for the oxygen, 2.688 is the mass, 2.688. It's got a unit grams after it, therefore that is the mass of oxygen divided by the atomic mass of oxygen here is 16. 2.688 divided by 16. 0.168. 0.168. So the questions we have to ask now are the same in every empirical formula question. First question, are these numbers the same? If they're the same, the formula will be MNO, but the ratio will be 1 to 1. These numbers, however, are not the same. So the formula is not MNO. Next question, which number is bigger? Very important question because we always have to have the bigger number as a bigger final number in the formula. This time 0.168 is bigger than 0.126. Okay, so now the final question is how much bigger? So we need to work out the ratio of manganese to oxygen in this compound. So to do that, we take the big number, 0.168, and we divide it by the little number, 0.126. That will make the little number 1, and we're going to find out the ratio now of oxygen by doing that. So we're going to take our 0.168 and we're going to divide it by 0.126, and the answer is going to be 1.3. Times bigger. Okay, so we've got 1 to 1.3. Now, to find out the final empirical formula, because what that tells us is the formula is now MnO 1.3. To find out the final empirical formula, we simply need to keep adding these together until we get whole numbers. So if I add another Mn and then O 1.3, I get MnO 2.6. Well, these are, so Mn2. So 1 and 1 is 2, and 1.3 and 1.3 is 2.6. These are not whole numbers. So this is not an empirical formula. The empirical formula is the smallest possible whole numbers. So let's add another MnO 1.3 to that, and now we get, we're adding those. So Mn2 plus Mn1 is Mn3, and then O 2.6 and 1.3 is 3.9. We'll round that to 4 in this case. And there is our final empirical formula. Now, that's a difficult question. If you got that, well done. All these questions, as always, on elshamhighchemistry.com.